All right, so here's the solutions. So just grade as you go along. There's no sense to, falsify it by any stretch. I don't think you would. Just grade it and then take a picture of the graded test and then email it to me. Or upload it to the assignment, I mean. Okay, describe the end behavior. And again, you're allowed to use your notes, the study guide, Desmos. So I picture you can have a great grade here. So describe the end behavior here. So the one end behavior, the limit as x approaches negative infinity. Order doesn't matter. If you did positive infinity first, that's fine. Of f at x equals. So where's the left end going? Notice it's horizontal there. At what y coordinate is it getting closer and closer to? So the answer is -1. And that's also true as it approaches to the right. So as x approaches infinity of f at x, same thing. The right and the left, they both are approaching negative infinity. That represents also a horizontal asymptote, and a way to describe it. Number 2, again, the limit as x approaches negative infinity, that's the left side. So the left side obviously is going to negative infinity. When I look at the right side, again, the notation matters that you're writing it correctly. It's a horizontal right there. So as it flattens out, what's the y coordinate that it's flattening out to? So if you count up, that is 5, even though there's no scale on the graph. So there you go. Number 3. Yes. If you got half right, give yourself half credit. Done. Okay, 3. Evaluate using a graph. So I'm going to go to Desmos for this. And so I'm going to stay on Desmos for this page and then until I go to where we're not using Desmos. So on Desmos fraction, negative 2x squared subtract 2x plus 4. And then the denominator is x squared subtract 4x plus 3. And so what we're looking for is this x approaches 3 from the left. So I want you to notice that at 3, the graph, if you look at it, there's an asymptote. It's invisible, but there's an asymptote. On the left, it goes to infinity, and on the right side, it goes to negative infinity. It says the little minus sign means from the left. So the answer to number 3 is infinity. If you put down does not exist, that is also correct. So either would have been the correct answer. Number 4. Let me write that equation in. So that equation is negative 2x plus 10. And then in the denominator, absolute value of negative x plus 5. So I'm looking at 5 from the right. So from the right, you can see the y coordinate. When you get to 5, it's undefined. But what is it approaching? What's the y value? And you can see it's -2. Number 5. So I'm just going to keep typing in the graphs off of Desmos and find the limits that way. So there's a negative in front, and then it's 4 over x plus 1. And it says x is approaching -1. Well, as x approaches -1, there's an asymptote there. And we're not looking for a one-sided limit. So for a two-sided limit, they would have to agree. And they don't. One side goes up, the other side goes down. So the only correct answer here is it does not exist. All right, number 6. That's negative. And it's x plus 1. And then the denominator is x to the 4th. So again, I want to look at as x approaches 0. So when you look at 0, what's happening is there is an asymptote at 0. But the right and the left both agree. They both are going to negative infinity. And so because they're both going to negative infinity, that is a good answer for a two-sided limit. You could also write down the answer does not exist, and it's also correct. For everyone you're doing correctly, give yourself a check mark. We'll add it up at the end. All right, 2 more to do with the graph, and then we'll get off the Desmos. So here's a piecewise. It's negative x squared plus 4x subtract 5. And that's good when x is less than or equal to 2. Then the second piece is x subtract 9. And that's good when x is greater than 2. So we're going to type that in, do the domain restriction with fancy parentheses, and you can see it here. You can see there's a jump. So this is a one-sided limit. So from the right, what is it approaching as it gets closer to 2? So as it gets there, obviously it's undefined, but right before it gets there, you can see what's the answer for 2 from the right. And I want you to notice that the answer is -7. That's what it's getting closer to. In fact, if I zoom in, I think you could see it better. That right there is -7. So again, it doesn't matter what it is when it gets there. It's what is it approaching. So it's approaching -7 from the right. By the way, from the left would have been a different answer, -3. And then there's a jump. So there is no two-sided limit here. The limit doesn't exist if it was a two-sided limit. Here we go, -4x squared plus 16. In the denominator, x cubed, subtract x squared, subtract 6x. All right, let's make sure I typed it in correctly, as x is approaching -2. So let me zoom out here just a little bit. So what's happening at -2? So I want you to notice at -2, and it's a two-sided one. Let's make sure I typed it in right. -4x squared plus 16, x cubed subtract x squared subtract 6x. So if I plug in -2, what is the limit there? So did I get it? So it's right there. Oops. So 1.586. There's a hole, right when I get there at -2. So there's a hole there. So it still exists. It's just what's the y coordinate? So if I look to the right and if I look to the left, what is it getting closer and closer to? The y coordinate. So 1.48. 1.572 on the other side, 1.67, 1.6. So I'm going to say the answer is pretty close to approaching 1.6. So if you gave an answer pretty close to 1.6, I would say you're correct off the graph. All right, next one. This one is a trig one. So this is tangent 2x. I'm going to change the scale so I can see it better that way. So I'm going to change the step. In this case, it's pi over 4. So I'm just going to make it pi over 4 as my scale. And then I'll zoom in for what I need to zoom in on. So you can see pi over 4 right there. So what's happening at pi over 4? And there's a little plus sign. So from the right, it's going to -infinity. And then from the left, it's +infinity. So there is no two-sided limit here. But from the right, you'd say the answer is -infinity, or you could say the answer does not exist, and both would be correct. All right, last one here with the graph. Again, trig, cosine, and it's 1 over x squared. So what's happening as x approaches 0 here? You can see it oscillates so much it becomes like, looks like a rectangle in the middle. It's going up and down, up and down, up and down. So the oscillation means that the limit does not exist. That's the only correct answer. So let me come back here so you can see it. So we went through it on Desmos. So did you write down does not exist or infinity? -2 does not exist. -infinity or does not exist. -7, an answer somewhere around. So if you said 1.5 or 1.7 or to 2 decimal places, you understood it. Give yourself the check mark. Number 9, negative infinity or does not exist, and then the only correct answer here is does not exist. So there is 10 there. So think of how many you got right out of 10. All right, turn the page. Number 11. So for these, evaluate it algebraically. So it's not going to be off a Desmos or a graph or anything like that. This involves substitution, factoring. This involves the conjugate to be able to evaluate the limit. So I know this is a polynomial. So all I have to do is substitute in to get the answer. So that's negative 2 cubed, subtract 4, negative 2 squared, plus 7, negative 2. Use your calculator correctly. And the answer is negative 22. Give yourself a check mark. For number 12, the limit as x approaches 5. So what I first do is substitute in and see if it's undefined or if it's indeterminate. So does that make a 0 in the denominator? No. Could it make a 0 in the numerator? It doesn't. So this is just a substitution. So I plug in 5 to get my answer. So that's negative 25, take away 2, and then 6 times 5 is 30. That's a great answer. If you decided to simplify it, another good answer could have been 3 goes into both evenly, negative 9 over 10. Both are correct. One is not better than the other. Give yourself a check mark. Number 13, substitute in. I need to know it's a real answer, and it is. And that's it. So substitute in and evaluate. So that's 7 take away 2. That is the square root of 5. Oh, no, sorry. That's a negative 1. I'm sorry. So that's the square root of 9 plus 1. So that's obviously 4. Give yourself a check mark. Substitute in. This is 4 to the negative 2 plus 1. Don't make it complicated. 4 squared is 16, and the negative exponent just means the reciprocal. And when you add a whole number and a fraction, right, that's not tough. You got it. If you wanted to write this down, beautiful. Both are equally beautiful. You don't get more points one way or the other. Number 15, do you know your unit circle? Or at least a calculator that knows your unit circle. Here, plug in pi over 3. You don't need to worry about asymptotes or breaks or jumps, oscillation for this. This is a wave, a continuous wave. But I'm going to remind you on the unit circle, just for those that want to be reminded. Pi over 3, in terms of where that is on the unit circle, it's right here. And the points there on the unit circle would be 1/2 and root 3 over 2. It goes with the x-coordinate. And the x-coordinate is 1/2. So it's 1/2 plus pi. Done. If you wanted to write as a decimal, 3 point, whatever it would be, 6 something, so be it. But there's the exact answer. Again, I'm going to substitute in. That's what that means. So at pi, where is that on the unit circle? The point there is negative 1 and 0. Secant's the reciprocal of cosine, which is the x-coordinate. So the reciprocal of negative 1 is negative 1. Square it. So that's 1 take away 4, so that's negative 3. Number 17. So step number 1 is, what happens when you plug in negative 4 to the top and negative 4 to the bottom? So I'm going to tell you that when you plug in negative 4 to the top and negative 4 to the bottom, you get indeterminate. It is 0 over 0. I do not want you to write down equals 0 over 0 because that's not mathematically correct. And points would be taken off that you wrote it down to think they're equal to each other. But we know it is 0 over 0, which makes it indeterminate. And because it's indeterminate, we're either going to factor or we're going to use the conjugate. So we have polynomials, so we are going to factor the top and the bottom. So to factor the top, that's plus 2 and plus 4. To factor the denominator, you first factor out a 2. Then after you factor, notice I'm still using limit notation until I do the last substitution. So we have x plus 2, x plus 4. The denominator, we have x plus 4 and x subtract 3 when you factor out that trinomial. Notice the whole divides out. Now you can substitute in. So when you plug in negative 4, you end up with negative 2 over negative 14. And that's a great answer. Negative 2 and negative 14. You could also write that as a positive answer because it's a negative divided by a negative. You could also write the answer as 1 over 7. All of those are good answers. Give yourself a check mark. All right, step number 1 for 18 is to plug in 1. If you do that, it's indeterminate. So we decided that we know that. That means that we're going to solve and evaluate this limit by factoring. So to factor out this, we're going to factor by grouping. So that's x squared. X take away 3, factor out a negative 1. X take away 3. And then factor out a 6x. X minus 1. Now we're going to continue factoring here until we divide out the whole. So the numerator, we have x minus 3 and x squared subtract 1. And then the denominator stays the same. Notice x squared subtract 1 and x minus 1, not yet. One more step to factor. What do you notice that could be factored further? So I want you to notice x squared take away 1 is a difference of squares. That's adding 1 and subtracting 1. So I did the difference of squares. Now I can see the whole that divides out. Now I can plug in 1. So if I plug in 1, no longer limit notation. So when you plug in 1, you get negative 2. Plug in 1, you get 2. Plug in 1, you get 6. So you can reduce it down or leave it as is. Negative 4 over 6 or negative 2/3. And you have your answer. So again, add up your check marks so you know what your score is. Number 19, again, evaluating a limit. In this one, we're going to evaluate it first by plugging in 4. Well, when we plug in 4, it is indeterminate. So we're going to simplify this using the conjugate. So that's 3 root x plus 6 and 3 root x plus 6, top and bottom. So I'm going to write the limit notation. And then I'm going to simplify it. So the numerator, I'm not going to mess with. It just stays beside each other. But the denominator, 3 root x and 3 root x. Well, 3 times 3 is 9, and root x is x. Negative 6 times 6 is negative 36. Nothing yet divides out. So I write down the limit as x approaches 4. The numerator, again, I'm not messing with, just beside each other. But the denominator, I can obviously factor out a 9. That leaves me with x subtract 4, and now the whole divides out. Now plug in 3 times root 4 plus 6 divided by 9. You can simplify it or not. That's 12 over 9. Or you can write it as 4 over 3. Both are great answers. Again, number 20. Can you evaluate a limit? First step is to plug in negative 1 and make sure it's indeterminate. It is. It's 0 over 0. Next step, we're going to multiply times the conjugate. So that's root x plus 5 plus 2. Root x plus 5 plus 2, top and bottom. So we have the limit as x approaches negative 1. The numerator, I'm going to multiply. So root x plus 5, root x plus 5, that's just x plus 5. And last times last, that's negative 4. The denominator, I'm just going to put them beside each other. Notice 5 take away 4 is 1. So this is x plus 1. So that divides out with the hole in the bottom. And now I can plug in. So what I don't see is a positive 1 on top. Plug in negative 1 here. So it's negative 1 plus 5. So the square root of negative 1 plus 5. So that's the square root of 4. That's 2. And then 2 plus 2. And you get a quarter. Give yourself a check mark if you were able to evaluate correctly. These questions to do with infinity have to do with end behavior. So for end behavior, we're looking for the power term. So the power term is the term with the greatest exponent. So I'm just going to write this down with the power term. So what's the limit as x approaches negative infinity of 3x to the fourth? That's really what I'm answering. So for that, understand that the power term is positive. So the right end goes up. An even exponent means both ends go up. And then when I look at the left end behavior, where is it approaching? You could also write this answer as does not exist, and it would be perfectly correct. Give yourself a check mark. Again, I'm looking at the limit as x approaches infinity. What do I see here when I look at the power? I notice the top is less powerful. That means this answer is 0, always. So when the bottom is more powerful, going to infinity or negative infinity, the answer is 0. So as soon as I know the top is less or the bottom is more powerful, there is your answer. Number 23. The limit as x approaches infinity, power over power. So the limit as x approaches infinity of x squared over negative 3x. I'm going to simplify this. So the limit as x approaches infinity. What you don't see is a 1 over negative 3. So it's really negative 1/3. And x squared divided by x is just x. This is a negative sloped line, like down 1 to the right 3. It doesn't matter about that. What matters is the end behavior. So a slope that's negative for a line, tell me where the right end is going, and the answer is negative infinity, or you could have said does not exist, and that's the correct answer. Again, end behavior. The limit as x approaches negative infinity in the power term. That's 8x over 10x. So reduce it down. The x's divide out, and all you're left with is a constant. It's a horizontal asymptote. So that constant, 8 over 10, is your answer. The right end and the left end is going to 8 over 10, or you can write it as 4 over 5. Both are great answers. Oh, you know what I forgot? There's a negative there, right? A negative 10x. That makes this negative. Makes this negative. So make sure it's negative 8 over 10 and negative 4 over 5. Give yourself half a point if you forgot the negative. All right. Add that up. How many check marks you got? Now we're at our home stretch of the exam, the test. The sequence questions, do not do. So if you did it, whatever. Those are empty questions. We're not doing that. That's connected to Calculus BC. 27. These we are going to do. Given the function that, find the slope of the tangent to the function at that point, then write the equation of the function in slope-intercept form. Now, I'm going to tell you that if you chose to do limits here, awesome, but the only time you would choose to do a limit definition of a derivative is if you are told you must do the limit. I see nothing that says you must do the limit. So I'm sorry if you did the limit as x approaches negative 2 or as h approaches 0, you'll get the same answer, but I'm not. So the derivative here. So first of all, x is negative 2. Y is negative 5. To find the slope, I need to do the derivative. So the derivative of that, I'm going to use shortcuts or rules. The power rule, 2 times negative 2 is negative 4x. And that's negative 16. And negative 29, that's 0. Then I'm going to take the derivative at negative 2, meaning I'm going to plug negative 2 into here. So negative 4 times negative 2, subtract 16. So 8 take away 16, that's negative 8. So part A says, find the slope. And the answer is negative 8. Give yourself a check mark. The next step is write the equation. Now, I'm not going to make you write it in slope-intercept form. So we write it in HK form, and that's perfect. If you needed to distribute and do it, but if you don't have to. Obviously, on an AP exam, they're not judging the form of the equation, just that it's accurate. So we're going to write down y equals, for the equation of the tangent line, and it's negative 8. The x coordinate, we change the sign, so plus 2, and the y stays the same, subtract 5. So did you write that down? If you wrote down negative 8x, that would be negative 16, take away 5, that would be negative 21. Both are correct. You don't get an extra check mark for that. But either one gives you a check mark. Let's try it again. Number 28. It doesn't say using a limit. Or does this one say using a limit? So this one says find the derivative using a limit. Notice the above one doesn't say using a limit. So because we're using a limit, find the derivative means I need to find the general derivative, not one just with 3. So for part A, to find the derivative, I'm going to use a limit as h approaches 0. The numerator is going to have that slope formula using x plus h and x, and then the denominator is just h. So there's your setup. I'm going to substitute in. So again, don't forget your limit notation. And you can make corrections along the way, and if you made a mistake, you're just learning. So where there's an x, I'm going to put in x plus h. Then I'm going to subtract parentheses and just put in the function. I'm going to continue to use the limit definition until I can plug in limit until I can plug in 0. So I'm going to expand here. That's x squared plus 2xh plus h squared when you expand it. That's minus 7x. That subtracts 7h. That's minus x squared plus 7h. So no parentheses, fully expanded over h. Now combine like terms. The x squared eliminates. The negative 7x eliminates. Oops, this should have been plus 7x. It eliminates. If you did it correctly, only the h's survive. So that's 2xh plus h squared minus 7h all over h. Factor out the h in the numerator. So take out an h from each term. For h squared, you still have one h left. Then once it's factored, the h divides out. You plug in 0. And the derivative is there, which is 2x subtract 7. So when you plug in 0, you have the answer. Now that you have that, what's the derivative at 3? So the derivative at 3, plug in 3. 2 times 3 is 6. Take away 7, and you get negative 1. So you get 2x subtract 7. If you didn't use limits, you don't get the check mark. And then negative 1, if you got that answer, however you did, you can give yourself a check mark. But there they are. Can you find the derivative using limits? And then use that at any x value to find the slope of the tangent line exactly at that x coordinate. All right, last page, here we go. Here we're using derivative rules. So can you take the derivative here using the power rule? 4 times 7, 28x cubed. 2 times negative 8, negative 11x. Check mark. Here, we're going to write this differently. The 4th root of x can be written as 1/4. We're going to add them together, the exponents. 1 plus 1/4 is 1 1/4, or 5 over 4. Then we're going to do the power rule. So the derivative here is 5 over 4 times 12. And then subtract 1 from the exponent, and you get 1/4. You can also simplify this because 4 goes into 12 3 times, and 3 times 5 is 15. This, by the way, is a good answer. If you wrote the answer as 15x to the quarter, that's a good answer. You could also write the answer as 15 and the 4th root of x. All of them are the same. You'd only get 1 check mark. Number 31. I'm going to write this as exponent, a power. So to write this as a power, that would be x plus 1, and it would be 3 halves. So notice the power 3 is there, but the square root gives it the denominator of 2. Now we're ready to take the derivative. So the derivative here would be 3 over 2 times 4, and you could just put them beside each other like that, and then subtract 1 from the exponent. So 3 halves take away 1 is 1 half. Notice in this situation the derivative of the base just gives you 1, so you don't need a 1 there. That's a great answer. What happens if you decided the answer was 12 over 2 or 6 in front? That's also beautiful. Or if you wrote the answer as the square root of x plus 1. Beautiful. But I'm saying that you don't need those extra steps. As long as you apply the rule, you don't need to keep going on from there. All right, number 32. There's 2 ways you could have done 32. So let's see which way you chose to do. So one way is to do the quotient rule. And the second way is to separate this into 2 fractions. So I'm just going to show you both. Both are correct, by the way. So if I separated this into 2 fractions, you would have 15x over 6 over 3x to the 4th minus 3x over 3x to the 4th. You would then simplify that. So that would be 5x squared negative 1x to the negative 3, and then you would do the power rule. So the power rule here would be 10x, and then negative 3 times negative is plus 3x, and subtract 1, and that's a great answer. 10x plus 3x to the negative 4. Or if you did the quotient rule, this is the other possibility that it could be. Both are correct. So with the quotient rule, a nice long fraction line, you would have done the bottom times the derivative of the top. So 6 times 15, what is 60, 30, 90. X to the 5th minus 3. Subtract the top. 15x to the 6th. Subtract 3x. And then we need the derivative of the bottom, which is 12x cubed. So that's all on top. And then the bottom we square. Now, if you combined like terms and simplified it, you would get the same answer. So either way, and this is a times sign here, 2x cubed. So both would give you that check mark. 33. This one we're going to do the product rule. So for the product rule, it is the first times the derivative of the second, that's 8x minus 1, plus the second times the derivative of the first. So that's 6x squared minus 3. No need to simplify that. So can you do the product rule? The first times the derivative of the second plus the second times the derivative of the first. Number 34. This one you don't have a choice. You have to do the quotient rule. There's no way to simplify it otherwise. So we'll get right to it. So the quotient rule is the bottom times the derivative of the top, that's 2x minus 4, minus the top, x squared minus 4x plus 3, times the derivative of the bottom. Now the derivative of the bottom is 1, so you don't need a 1 there. But if you went times 1, that's fine. And then the bottom squared. All right, number 35. So give yourself a check mark. Here are the last questions for the test, and then you can take a picture, grade it, take a picture, and then upload it. All right, what's the average rate of change? So the average rate of change, that's AROC. That's algebra. So we're given a function up here. So that's going to be from 80 to 90. So T is the number of years since 1970. So 90 would be 20. So it's P at 20 minus P at 10. Because 10 years after 1970 is 80, and then 20 take away 10. If you used your calculator, you would get the answer -4. But realize that T is that P is in thousands. So it's not -4, but -4,000. So did you write down the answer as B? That means it's decreasing the population. The average rate. That's what the negative means. Not that there's negative people, but it's decreasing in size at that rate. So a rate can be negative, but people can't be negative. 34. So same equation, instantaneous, the IROC. So I need the derivative. So the derivative is 3 times 0.03, that's 0.09. Subtract 1 to the exponent. Again, 2 times negative 1.5 is negative 3, t, and then plus 20. Then, for the derivative, you plug in 1973, that'd be 3 years after 1970. And then the approximate answer is 11.81. So again, in thousands, that would be 11,810, and this answer is A. What is the average velocity? So again, you have a different equation for a ball thrown straight up. This is height, and time is in seconds. So average velocity, that's AROC, that's algebra. So from 0 to 2, so in this case it's h at 2 minus h at 0 over 2 subtract 0, average velocity. So plug in 2, plug in 0, and so on, do the work, and you get 148. Subtract 92 divided by 2. That answer, as a rate, is 28. So the answer was C, 28 feet per second. Last one, then we'll add it up. So what is the instantaneous? IROC is the derivative. So I need to do the derivative first. So the derivative of 92 is 0, and then we have 60. And then 2 times negative 16 is negative 32t. Then we take that derivative and plug in 4. So if I plug in 4 for t and then simplify it, so that's like 60 take away 128, that's negative 68. So the instantaneous one there is negative 68 feet per second. That doesn't mean that the height is negative. It just means the negative for a rate means it is falling. The direction it's going is the height is decreasing or falling. Give yourself a check mark if you did it correctly. And now let's add it up. So there are 38 questions, but we did not do 2 of them. So when you go back to the beginning for the exam, the test, it's going to be out of 36. So make sure your name's on it and all that. Give yourself. I'm sure you got 36 out of 36 or something close to it. Anyways, I'm proud of you. I'm sure you did great on this test. And until next time, all right?